Well, hello, honors geometry students, and welcome back to some geometry. I'm just trying to find one of my favorite pieces of candy. Oh yeah, you guys weren't here for me to give it out, so I'm just gonna have to eat it all myself. It's my tradition on my birthday to hand out candy to students, but you aren't here, so I'm gonna eat it. It's okay, I can handle it. Well, this week we did get some new additions because it was my birthday. I got new markers. I'm very excited. So I have red and green and everything. And look at this, I got a new whiteboard. I am very excited about that. So let's get started. We're going to be doing 12.4 and 12.5 this week. And remember, on Wednesday, don't forget to take the quiz. Quiz Wednesday, every other Wednesday discussion post. So we don't have too many more to do. This quiz will cover 12.1, 12.2, 12.3, and radians. So call or email if you have any questions. We want you to all do really, really well on that. So that's, again, until, well, it'll be 9:30 Thursday morning, but essentially I'd like for you to take it on Wednesday. Okay, let's get started here, and we've got some, I just think some really great thinking questions. So this is one of my favorite sections, but we do have a little bit of new to go over first, okay? Central angle isn't new, that is the old. So 12.4 is inscribed angles. So we already know the central angle. Now we want to talk a little more about that intercepted arc, because that's going to become important for me. So when you're looking at the central angle, remember the center of the angle is at the center of the circle, and then the two sides are radii. The intercepted arc then is always the shortest distance between the two sides of your angle, okay? And then remember, because we had this before, this isn't going to be too bad, but remember my central angle is angle equals arc. Now I'm going to circle that because, believe it or not, that's the one that's missed on the last quiz. This won't be on this week's quiz, but the last quiz. So make sure you remember that. The central angle equals the arc. Central angle equals the arc. So the measure of angle 1 is simply 50 degrees. Now, we've had that word inscribed before. So inscribed, remember we had in chapter 5 where we had inscribed polygons, and every vertex of the polygon was on the circle. So that's really what we're looking at today, is just looking at saying I want an inscribed angle when it's one angle of an inscribed polygon. If I were to make this segment, it would be an inscribed triangle, okay? The intercepted arc is still going to be very important. Now we no longer have radii as sides of our inscribed angle. We now have two chords. And remember, the diameter is a chord. So my intercepted arc is 50. Now, obviously connected, so that's why I wanted to make sure we reviewed the central angle here first. So let's see if we can figure out how this connected. If this is 50, what's the measure of angle 1? Exactly right, the measure of angle 1 is 50 degrees. I'm going to go ahead and erase that and put 50 degrees right here. So now let's remember, let's use this pretty pink one. What kind of angles do I have here? They make a straight line, linear pairs. So if this is 50, this would be exactly supplementary, so 130 degrees. So we were saying, okay, if this is 50, the central angle is 50, the supplement is 130 degrees. Now we want to look at this new triangle that has the central angle of 130 degrees. What kind of triangle is this green triangle? Well, remember what a lot of you were having some struggles with. The radii are always congruent. So I really just have an isosceles triangle. And what do you know about an isosceles triangle? Base angles have to be congruent. So really all we're doing is saying, okay, 180 minus 130, we're back to the 50, and then we have to divide that by 2. So the measure of angle 2, to make 180 degrees here, would be 25 degrees. So I'd have 25, 25, 50, 50 plus 130, back to our 180 degree. Remember, every triangle has to be 180 degree. Now, we don't need to do all that, do we? So we're not going to go through the isosceles triangle. We're not going to go through the linear pairs because that's just a lot of work. What could I do to find the measure of angle 2 from that 50? You got it. All I'm going to do is say my angle equals half the arc. So in 12.5, we're going to be finding a lot more different angles, so I think you're going to find that this is going to be important if you can just kind of remember the basics, so you have it on your reteach all out in words.
Sorry,
but I'm going to look at just the basics here. So inscribed angle equals half arc, okay? So obviously then we could do several different questions here. I'll take a look at one here and see if we can develop some of these theorems here. So now we know, let's take a look at what happens if I give you circle O. So remember that's the name of the circle, means O is the center of the circle, and I want to find angle 3. Assume that touches at one point. I want to find the measure of angle 3. Well, I would still see that angle 3 has its vertex on the circle. It has two sides that are chords of the circle, so it is still going to be an inscribed angle. So now I need to look at what is the intercepted arc. Well, if I go from one side to the other side, there you go. That would have to be, because this is a diameter, a semicircle or 180 degrees. So what's the measure of angle 3? Half the intercepted arc. The measure of angle 3 is half of 180 degrees or 90 degrees. So it's very, very simple today. Intercepted arc, half the measure of the, inscribed angle, half the measure of the intercepted arc. Okay? Now that brings us then to our theorems. Our first theorem is just that an inscribed angle equals half the intercepted arc. And then we had our second theorem, an inscribed angle in a semicircle is always a right angle. So I don't even have to do anything. If I see it's inscribed in a semicircle, it's going to be a right angle. So if I were in class, I'd show you a little videotape that would say, oh look, that would have to be a right angle. If I come over here, that would have to be a right angle. I could come up here, that would have to be a right angle. Okay, so I could spin that around and it would become a right angle every single time. Okay, now what happens if they want you to do a little algebra problems? So we'll have some that are little algebra problems on here. Oh, let's just do a real basic one since I will be giving you your reteach worksheets. Let's say that this inscribed angle is given to us as 3x degrees. And then I have a second inscribed angle, and its measure is given to us as 2x plus 20 degrees. How would I find x? Well, you say the inscribed angle is half the intercepted arc. So I go back to my two chords ending on the circle here and here. So my intercepted arc is here, but I didn't give that to you. Any ideas? Okay, you can kind of see now this inscribed angle, the blue one, also has the same intercepted arc. So if they have the same intercepted arc, 3x is half this orange arc, 2x plus 20 is half this orange arc. So you can see then our third theorem, two inscribed angles that have the same or congruent intercepted arcs would always have to be congruent. So if this directions, I didn't put the directions on here, said find x, you don't have to go through the 1/2 the intercepted arc. I would simply say 3x is equal to 2x plus 20. I told you I'd make you an easy one here, and x would equal 20. Okay? So anytime they have the same intercepted arc, they would have to be congruent. Do you see any other inscribed angles that would have the same intercepted arc? You got it. This angle and this angle. Because this inscribed angle has this intercepted arc, this inscribed angle has this intercepted arc. So according to that theorem, those would have to be congruent as well. Okay, our last theorem, probably our most useful, works with an inscribed quadrilateral. So obviously, if it's an inscribed quadrilateral, how many angles are going to be inscribed angles? We're going to have 4 of them. So let's just call them A, B, it's not any particular, so don't make it into any particular shape. And let's just call it ABCD. Now we want to look at our last fact, okay? Let's take a look at angle A. Angle A is still an inscribed angle because it has two chords. Its vertex is on the circle. Its intercepted arc would be arc BCD. So angle A would be half the measure of arc BCD. But I didn't give you arc BCD, okay? Because I want you to look at it in comparison to its opposite angle. Opposite A would have to be C. And remember, when you're naming a quadrilateral A, B, C, D, opposite would have to be every other one. So A and C have to be opposite. What kind of angle is angle C? Obviously another inscribed angle. Where is its intercepted arc? So you get what we're looking at? C is half the blue arc. A is half the orange arc. Well, what's the blue arc and the orange arc going to equal? You got it. It's a circle, 360 degrees. So we come with our last theorem then. Opposite angles in every inscribed quadrilateral have to be supplementary because they have to be half of 360, so they'd have to add up to be 180 degrees. So that's going to be like if I say this angle is 3x degrees and this angle is only x degrees, then I'd say, okay, then I know they have to add up 3x plus 1x to give me the 180 degrees. Okay, so again, we'll get into some more difficult ones here, but it would just be 4x equals 180 degrees, or I guess that goes in there, what, 45 times? And that would be my angle. Okay, would there be any other angles that are supplementary? You got it, it's exactly right. So if this angle, let's just say it was 80 degrees here, what would this one have to be? 100 degrees, exactly. So these are our four theorems that we're going to be looking at here today. And then I want you to look at, while I erase the problem, go ahead and write this problem into your notes, okay? So we're looking at finding different measures, okay? And I'm going to erase some of this so we can look at it on the board. If I can get that to stay up while I erase the board. I think we got it. Okay, so we get enough room to work on that. Okay, so you can see the reason I wanted to get into one of these is that your reteaches don't get into as difficult questions as what you have obviously on your homework, because you have a lot of review on your homework. So if you look at that now as, okay, how am I going to do that problem? Right? I'm just going to try to see if we could just put it right here so we could still see it a little bit. Don't know if I can get it to stay there. Let's see if we can. There we go. Okay, so let me see if I can bring that up here. So any ideas on how you're going to start this problem? Okay, well, let's just put it up here. Okay, so we have, if you're going to do this problem, you're going to be looking at what reviews, okay? So the first one we want to do is to find the measure of angle EAD. Well, EAD, it should be an easy one for us. So EAD is just this angle. It's half its intercepted arc. So my answer to number 1 would just be 1/2 of 80 degrees or 40 degrees. So that one's not too bad. So I had to give you an easy one to start off with. Did you get number 2? The measure of arc AEC. So where is arc AEC? Well, remember it has to start at A, go through E, and come over here to C. So arc AEC would be all of that. Now remember, my dot or my center is here. So I don't have a semicircle, so I need to look at it and see what can I get so that I know all of these different arcs. So sometimes it might be beneficial for you just to get all the arcs that you do know. So I have an inscribed angle here. I have an inscribed angle here. So I have 130, okay, You see it? So what would this arc have to be? Oh, well, that's going to be the answer. I'm looking at this inscribed angle, angle B, angle ABC, and my AEC then, my angle would equal half the arc. Well, my angle is 130 degrees, so 130 would be half of what arc? You're exactly right. So your answer would be 260 degrees is equal to that arc. Okay? So now we know this whole pink arc is 260 degrees. So we can move on to number 3, where we were trying to find the measure of arc DC. Well, arc DC is this arc. So how can I find arc DC? Well, I have to look at what they gave me. So here's the review in this. This has an arrow on it, as this has an arrow on it. So of course, if they're arrows, that means what? They're parallel, and so therefore, these would be supplementary angles. So that would have to be an angle of 50 degrees because those two would have to add up to 180 degrees. That makes sense? Okay? And then we have these two chords that are given to me as congruent. So if those chords are congruent, then their arcs have to be congruent. So we want to think about that as well. Now for this one, they just want us to know arc DC. Well, we already know all of this is 260, okay? So if we could just figure out what each of these are, then we could probably figure out the whole thing. Okay, so if I say this is 50 degrees, then that means this arc has to be, the intercepted arc, 100 degrees. So B to D would have to be 100 degrees. Okay, so now I know this is 260 degrees. This is 100 degrees from here to here. This is 90 degrees. This is 180 degrees. Okay, so would we be able to find out a B? So we're looking at 40 degrees, 130 degrees, 50 degrees. What about arc AE? Could we find that out? Okay, so this is what we're looking at. DC for this one and AE for this one. Okay, I'm going to give you a minute to think about that here as we go on here because I don't want to take up too much time here. So think about those two and we'll come back to that. As I said, we're trying to give you a little bit more problems so that you won't have so much trouble on any of the homework. Okay, so what I want to look at now, we said we were doing 12.4 and 12.5. And 12.5 is a super, super easy fast. So we can come back to the rest of that example as we get going on this one. Okay, so now in 12.4. You can see in 12.4 that all we have, sorry, I have to push that down so it doesn't fly away from me here. All we have is angle relationships in circles. So we're looking at angle relationships in circles and saying what has to happen if I have an angle relationship in a circle. Okay? Well, I said there has to just be one of 3 things. Oh, here they are. I got new things. Look at that. This is what I got for my birthday. Okay? Isn't he cute? Not a bunny, but he's going to get ready for some chips and some salsa because he's reminding us we had a joke from last week. And that was, why was the cord upset with the tangent after the race? Why was the cord upset with the tangent after the race? Anybody figured out? He came in secant. The cord was upset with the tangent because he came in secant. I like this one that people sent me too, is why was the obtuse triangle frustrated? Why was the obtuse triangle frustrated? He's never right. You guys are really making me laugh. Okay, let's take a look at why I said this is going to be easy for us here. Because really all we have to finish this up, and it might even be helpful for the other examples, that's why I thought we'll just start in on this, You really have three things that can happen with an angle. Now, you can make the angle in a lot of different ways, but the angle is either going to be on the circle, the vertex of the angle. The vertex of the angle could be inside the circle, or the vertex of the angle could be outside the circle. Now, you're going to find that you can make those by different secants, tangents, etc., but really it narrows down to just these three things. Okay, so let's go ahead and start this one. Do we already know how to do if the angle is on the circle? We certainly do, because that's just an inscribed angle. So we say, okay, that's just the formula. Angle equals half arc. So that's really our first theorem in 12.4, is to expand on what you already know. So it's not going to be too bad. So that would be just exactly like we had from before. If this is 100 degrees, the measure of angle 1 would be 50 degrees. But now we're saying, hey, we can do that even if I have one chord and one tangent. Okay, so I could still say if this intercepted arc is 100 degrees, then this angle is half the arc. So it just expands what we already knew, so it's not too difficult. I'm just expanding it and saying anytime the vertex is on the circle, take half the intercepted arc. So the measure of angle 2 would still be 50 degrees there. Okay? And then of course we could go backwards in it. If I say I have, let's go with a, so if I tell you what the angle is, then I should be able to say what my arc is. Well, I gave you an example here where I wouldn't need to do that, because what's the answer to this one? Now, if it goes through the diameter, you got to look for that 180 degrees, so that angle would just be 90 degrees. Okay, so what happens if they give me the angles? Let's just use this picture. If they give me the angle is 47 degrees, how would I come back to the arc? Okay, exactly, because 47 is half the arc, so my arc would be 94 degrees. So just let the algebra do the work for you, and it's still the same relationship. So all we're doing in 12.5, angle relationships in circles, the first thing is just expanding on that inscribed angle. So I want you to think inscribed angle, but just say anytime the vertex is on the circle. But look for things like semicircles, radii being congruent, etc. So what do you suppose you're going to do if the angle is inside the circle? Now it's important to say that this is not the center of the circle. So let's say the center of the circle is over here somewhere. This is not the center of the circle. We'll come back to when it is the center of the circle. So let's say this is, let's say this side is 80 degrees and this side is only 60 degrees. So now we still have our intercepted arcs. So we haven't gone away from what we had from before. Just like over here we had our intercepted arc, it was just half the arc. Now we have the intercepted arc, but we have to go on both sides. So now think about that. Would this be reasonable to say it's 80? Well, if that's true, then over here I'd have to say that's 60. Is it possible for this to be 60 and this to be 80? Exactly. So when you're working with the inside, you've got to look for vertical angles. And of course, we remember that the vertical angles have to be congruent. So it's not possible for that to be 80 and that to be 60. Okay? So now we're going to say, okay, how am I supposed to get it? Well, you can kind of guess as to where we're going to get at now. It's not going to be 80, it's not going to be 60, but our formula, our angle is equal to half. Add the two arcs across from the vertical angles. So you always just go from the vertical angle opposite and say, okay, add the two arcs here. So the measure of angle 2 would simply be 1/2 of 60 plus 80. So I'd say measure of angle 2 is half of 140, or it's 70 degrees. Makes sense. It's right in the middle between the two. Okay? So not too hard when our angles are on the inside. Now I said let's go back to what happens if it were a central angle. If that vertex were right on the center, then wouldn't that angle have to be 80? But then the vertical angle would have to be 80, and what would this arc have to be? 80. So again, if it was on the center, I'll just draw a small one where it's on the center, you could do the same thing. Let's go back to that example that I started with 50 degrees. if I just drew the other two radii, I would say this is 50, this is 50, this is 50. So it still works if you want to continue and say, I need both vertical angles and I need the arcs on either side. I could still say that's half of 50 plus 50, but who would want to do that? So we don't typically do that. The central angle we just know is equal to its arc. Okay? Now you do have to be careful with these because they may ask for an angle that you think, oh, I can't get it. So let's go with one other quick example here. What happens if I ask for the measure of angle 3, but I give you that this is 50 degrees and this is 40 degrees? Well, here's the problem. My intercepted arcs are over here, 50 and 40. Okay, so I'm not finding the angle in between. So I just go ahead and find the angle that's vertical from it because I know those two have to be the same. So that means that this angle is 1/2 of 40 plus 50, or of course that angle would have to be 45 degrees. So that's 45 and that's 45. What am I saying you need to look for? And I apologize that this screen has a glare on it because it's the filming or the computer. Okay, but if this is 45, just remember, I just dropped my lid, just remember you still have to go with stuff from the review. What kind of angles do you have right here? Okay, so it's not going to be bad. You just got to remember a lot. That's why I like chapter 12, because it's a lot of review, which usually helps us for the quarter or the end of course exam. But this year we can just go back and say, oh, it's not so bad if we just see the review. So I don't have angle 3 yet. I just have the supplement of angle 3 because I have those linear pairs. So the measure of angle 3 then would equal 180 minus 45 or 135. Okay, so again, the big key is find the vertex of the angle. Okay, and I know you could name it with a lot of different names, which is going to be on your reteach, but really if it's on, it's just half the arc. If it's inside, the vertex of the angle is inside, it's half arc plus arc. And now what do you suppose it's going to be if it's outside? Well, just remember inside and outside are opposites. So here, I just do the opposite. I'm going to say, instead of arc plus arc, I just do arc minus arc. So if the angle is on the outside, it's just half of the two intercepted arcs. Now remember, an angle has to have a measure that is positive, so I can't do small arc minus big arc. I'm going to be looking at the arcs between these two secant segments. So I'm going to be looking at these two arcs. So the measure of angle 3 would just be this arc minus this arc and then half of that. Okay, so let's say that this was given to us as 80 degrees and this was given to us as 30 degrees. Then the measure of angle 3 would just be 1/2, 80 minus 30. 80 minus 30 is 50, half of 50 is 25 degrees, and that's my measure of my arc. Now the good thing with this is that it doesn't work with just two secant segments. It also works if I have two tangent segments. So what happens if they want the measure of angle 4, let's put here, and they give you that this arc from tangent point to point of tangency is 100 degrees, and that's all they give you. Well, I still have to look at it and say it's a vertex on the outside, so angle equals half arc minus arc, so angle 4 is going to equal half this arc minus this arc. Some of you are catching on. You have to remember that the circle has 360 degrees. So that's another review. It's just a lot of review on this assignment. So this is 360 degrees. That would make that 260 degrees. And I would simply say the measure of angle 4 is equal to half 260 degrees minus 100 degrees. So that would give us 80 degrees. Okay, and I'm kind of running out of room there, but the last example says, hey, you do the exact same thing, even if it were a secant segment and a tangent segment. Okay, so if I do a secant segment and a tangent segment, so it could be 2 secant segments, it could be 2 tangent segments, or it could be one of each. The key is, where's my vertex? It's still on the outside, isn't it? So again, just be really careful. So let's say this time the 100 degrees is given to me from the point of tangency over to the end point here. So this is 100 degrees. How am I supposed to find this angle? Let's call it angle 5. Well, just like you had to go with the circle being 360, you have to also look for semicircles. So this would have to be 80. So the measure of angle 5 would equal 1/2 of 100 minus 80. Or the angle would be 10 degrees. Okay, so that's not too bad. So again, you want to go ahead and let's take a look at what happens when they give you a little bit more difficult problem. So let's write this problem in your notes here, and then we'll see if we can solve that. Okay, and I'll erase everything on the board so we have enough room to write it or to show the answers here. I'll leave the formulas up there. Okay, and so now they may put things all together. So you may have one problem that has an inside vertex, and then another part of it has the vertex on the outside, another part of it has the vertex on the circle. So you have to be looking at all that kind of stuff. Sorry if I'm shaking that around here, but let's go ahead and see if we can work that. Okay, so first of all, we want to find the value of x. Now it looks like we have an example then of which decision here. Inside, outside, or on. Obviously on the outside, so we can say the measure of angle T is 1/2 the larger arc minus the smaller arc. Well, our larger arc is x. The problem is, how am I going to find this one? So I can definitely put in my number. 15 is equal to 1/2 x minus, well, should I just use another x? Well, if you do that, you're saying these are the same size. So there's a couple of ways you can do it. If you don't know it, you could introduce a second variable. Let's just call it y. So I would know that 15 is equal to 1/2 x minus y. Okay, double that makes it 30 equals x minus y. Now, how am I supposed to solve for x if I have an x and a y? So I remind you, 2 variables, 2 equations. So I got to go back and say, hey, look, there's something here that I didn't use. I still have an 80 degrees up here that I haven't used. I also have a diameter that I haven't used. So that means that they're giving me an entire semicircle here. So my second equation would be x plus 80 degrees plus y degrees is equal to 180 degrees. Or x plus y is equal to 100. So just wanted to review a little bit on those systems. I can't let you go too dry on that because you're going to be into Algebra 2 soon. I can't believe we're almost done with geometry here. So now I have my system. Let's go ahead and put this one right down below it here. Go back to red. So we have x minus y is equal to 30. Oh, look at that. The y's already drop out. So I have 2x is equal to 130. And I get it solved pretty quickly. X is equal to 65. Okay? So all we had to do is find x. Okay, let's do one last example from 12.5. And it's, I'll give you closer here. 2 tangent segments intersect at one exterior point, forming a 50-degree angle. Find the measure of the major arc formed. Okay, so let's say if we can look at that. Well, what are we going to do if it doesn't have a picture? You're exactly right. We're going to put that picture in. So 2 tangent segments from the same exterior point. So I just draw in my 2 tangent segments. Assume I can hit that at being a point of tangency there and a point of tangency there. They make a major arc that I'm trying to find, okay, and a minor arc, which I don't know. So I'll put an x and a y. So we're trying to find x. Okay, and it says the angle formed was 50 degrees. So you could see, probably the easiest, again, just to use a system of equations. So I have my vertex on the outside, so my first equation could be 50 equals 1/2 large arc x minus small arc y. Or 100 is equal to x minus y. Or I'm going to get my second equation. Yeah, some of you are remembering the whole circle. So I know the whole circle equals 360 degrees. And again, not too difficult to solve. My y's drop out. 2x is equal to 460. Divide by 2. So 230 degrees is my x. Okay, I think you guys are catching on pretty well there. I hope that if you have any questions that you will call or text me. And I have to answer one more of these jokes that you guys sent in. They were so funny. Why is it sad that parallel lines have so much in common? Why is it sad that parallel lines have so much in common? Because they'll never meet. Okay, you guys have an awesome week. Call or text anytime or email me. Have a good week. Bye.